All right, and we should be live. There we go. That's nice. Um, let's see. Did I just get a notification on my phone? Oh, yep, from myself. Yes, they want a link like that. See, I have no idea what I'm doing. Yeah, oh, I already did that. See, yeah, it's fine. Do a little Discord. Uh, let's see, this is me. Yeah, let's enter that. Post. A little bit like that, and then yeah, we can start. So, um, as I said in the announcement post, I am making a digital watch for myself. I wasn't quite happy with the fact that after my Apple Watch broke, I needed a new watch. And if I wanted a vibrating alarm that could go off more than once, like that had a snooze function, that had timers, multiple timers, things like that, that costs like 200 plus Canadian dollars, which is crazy. I have like a Casio watch right now. That's I don't know if you can see that. Yeah, that's fine, but it only does one timer or one alarm. The alarm only goes off for like 10 seconds at a time. It's kind of crazy that it can't do more than that. And this watch new is still like $50 Canadian, and it does barely anything. And I think that's kind of ridiculous. So I spent way more money than that to get a little microcontroller dev kit that we will be trying to use to make a digital clock. I also have an e-paper display and like a timer component thing. And we'll see if I can actually make something with this. Hello, hello, Alexis. Welcome, welcome. So yeah, we'll see how this goes. The first thing I need to do is really just dig up the specification sheet for the ESP32 microcontroller. And really, I just want to get set up today. We'll see. Yes, I do have a plan. For making a watch, yes, I do have a plan. First thing first, I just want to get the microcontroller set up. Which I'm pretty much just going to follow the getting started guide from Espressive, who made the microcontroller, and get that working. And once that's done, we'll see where that takes us. Let's see. They have a little getting started guide, but I'm also wondering if the dev kit does power to. That would be real nice if they did that. Yes, nice. There is perfect. There's a 3.3 volt power supply. That's gonna be nice on the deck kit. That's number 18. God, this is so small. This is what you get when you get old. Can't see stuff. Okay, there's another ground there, I think. These are 2 power. This is probably, yeah. It's that side. So we have 3 volt, and then we got 3 volts ground, 5 volt power. Nice. Okay. I'm just gonna hook up the ground and the power, and we'll go from there. Okay. Let's see. This is also going to be fun because I have absolutely no electrostatic discharge protection stuff. So I'm just gonna hope I don't build up enough charge to actually make anything go boom. Okay, let's do the positive. So that's 3.3 here. Why am I starting to feel like Alexis over there is a bot? Oh. At least you're recording if it makes a boom, yes. Okay, there we go, okay. I'm very happy you're not a bot. Oh, really? Nice. Welcome. I've never really had a viewer before. Only spam and bots, so I am naturally a little bit suspicious when people come into chat. And yes, there will definitely be a recording if things go boom. So yes, I do have a plan. I'm not gonna go so far as to say that I'm basing this off of other like smartwatch projects. I haven't looked at any code, but there's an open source project called Open Smartwatch, I believe. Let's see, let's check. Open Smartwatch. Yeah, Open Smartwatch. There's also Watchy, and I based some of my component selection off of those projects. The microcontroller is based off of those projects. They both use an ESP32, different versions, but the same architecture, same controller. And the timer component, I think I got from. I'm using the same one that the Watchy uses, and then the size of the e-paper display that I got is the same as Watchy. I couldn't find the same e-paper display, so I just got whatever I could find that was roughly the same size and didn't cost too much, and that's what we have. So I almost have this hooked up right now. Let's do the last one. It's gonna be this one. I think this one is big enough. Oh no, that's okay. You're all good. It was more your questions were all open-ended, and I just wasn't sure if it was leading to like a bot question of like, come to this link to chat more or whatever. So it was more the open-endedness of the questions than anything else. But you're all good. You're perfectly understandable. Let's see. That wasn't quite big enough. I guess I'll just use a different color. It's fine. It's just hooking up the power. I have the ground in the same color, but this should be good. Don't connect that to ground, please. Hmm. Hmm. This is I think I can get it like this. Yeah, let's see. No, that's all good. You can post memes. As many as you'd like, in fact. I probably won't be opening them while I'm working on this, but feel free to share. Okay, so okay, I've got this hooked up. Nice. Okay, beautiful. Now, let's see. Guess we'll start with the getting started. Hmm. All the pins. Nice. Nice. Button. Open boot and then press EN. Oh, nice. Okay. Got boot and reset. Boot, reset. Okay. That's nice. Let's see. Okay, so please, yep, it is. I have a USB cable connected to my computer. And we're going to want installation stuff. I'm gonna try to do this in C. Ideally, I would like to do this in Zig actually, but I don't think Zig is ready to compile to this architecture yet, or at least I couldn't find anything like that. Using VS Code is probably going to be easiest, isn't it? Let's check that out. Yeah, we can go manual installation Linux and macOS. What does this do? This is going to be nice because it has a debugger built in. That's really good. I will have to install the prerequisites anyway. What does this give me? Okay. Oh, it has the examples and everything in there. Nice. Okay. Okay, yeah, no, this is gonna make this much easier, I think. Let's see. Do. And the thing is, I wanna at least see what this gets me. Probably have most of these. So we want CMake, Ninja, and directly to that one. I probably don't have. I know I already have the command line tools installed. Oh, I think I have Ccache as well. I should already have Rosetta installed too. Oh, yes. Is this better? I don't know if I can make this. That's a little larger now, I guess. Sorry, I forgot to increase the size of the fonts. Um, I can also increase the size here. I think, yeah, I don't even have a regular Python installation. I do have Python 3, and yeah, it seems okay. Oh, and Ccache. And then we want our library for this perceive. This would be downloaded by the VS Code extension if I choose to use that. This compiler, debugger, Python packages. I do not plan to do this. Hmm. Okay. Oh, okay, nice. Nice. Does this give me a debugger is the real question. Probably does not. This does build it. And then flash it. Mm-hmm. Okay. Okay. I think probably gonna want to go command line route. That is probably gonna be more useful. But we can start with VS Code. That's fine. I have not updated that in a long time. So let's start by doing that. Sure. Check updates. Let's do this. Yep. And we want to look for, what's it called again? Search for, what was it? ESP IDF. ESP IDF. Alright, yes. They have a web extension? Heck's this? Oh, when you're working on web, okay. That makes sense, I guess. Yep. I think I do want to go the advanced way of doing this. Sure, GitHub, that's fine. Or I think I'm gonna drop this and go that here, the container. Yeah, that's the correct Python version. I want this, I think, to be in not local / expressive. That seems good. Bigger tools. This probably does the CLI installation for me too. Is the size okay in VS Code of like fonts and stuff, or should I make that bigger too? Just probably make it a little bit bigger. That's probably better. While we wait for this, just message my wife real quick. Right, then I'm gonna want to fix the USB cable a little bit. Is this the correct type? Yeah? Yes. It's an ESP32 Pico. Rux. It's an ESP32 Pico. I'm just setting up the tools right now. Sorry, things seem small, Alexis. I'm hoping you can at least see some things while I'm working on this. I can zoom in more when we start working on code, if needed. Okay, so once this is set up, what are they expecting us to do? Build your first project. Nice. Wi-Fi and Bluetooth. Yeah. I actually probably won't be using Wi-Fi and Bluetooth. I'm probably going to turn those off to save on power, at least to begin with. If I ever do make this an actual watch, then it's going to be nice to have those capabilities um, if I want to use them. The only thing I would really want is maybe to see notifications from my phone, but that's like a huge thing to get that working as far as I understand it, especially since I use an iPhone and that's kind of closed down and requires an app on the phone, I think. So that's future stuff. For now, I just want a digital watch that can do several alarms and that I can snooze when the alarm rings. All right. I need to step away for like a minute to go get the baby monitor. It's a small chip. This here is a development board. I don't know if you can see this properly. But like the chip itself is tiny on here. So I'll see if I can find the photo of this. Oh yeah, like this is the chip itself, which is like the square right on here somewhere. I don't know if you can see this well enough. The chip itself is tiny. This is a development board, which is why it has a bunch of extra pins. If I ever made this into a watch, I wouldn't use the development board. I would use a printed circuit board with just the chip on it and all the components done for me. I will be right back. I have to get the baby monitor. Hang on. And I'm back. So yeah, I would put it on a PC. Well, not I wouldn't put the dev board. Like this isn't going on a PCB. I would order like there are services online that can make a printed circuit board for you. Okay, yeah. Just in case anyone else is on here that's curious, a printed circuit board is a thing like this, where the connections have been made really small. It's all soldered together, and it's typically how electronics are delivered. This here is just going to be a bunch of wires and things hooked up very ad hoc. This is a more finished product, and you can find places online that will make these for you. You just have to give them a drawing and the components you want in each place, and they'll print the circuit board, connect all the components, solder everything together, and then deliver the circuit board to you. That's what I would do if I can actually get things to work. Let's see. Do we have things installed now? Yeah, I guess we need to download the tools. Shouldn't take long. Okay, get a debugger, compiler stuff. All right, that's nice. And the display for the watch is going to be an e-paper display too. I got something similar to what the Watchy open source smartwatch uses. I hope it's going to be that simple. I really do. I'm actually gonna yeah, I'm gonna have to like draw numbers. I don't plan on using a higher level graphics library, even if I probably should now that I think about it. Might make things easier, and this doesn't really need to be super performant. But for now, I'm planning to just do this myself, which is going to mean constructing arrays for the e-paper display to actually do stuff and draw things, and then sending that over a serial port somehow. We'll see how that goes. No, I was initially planning on just ripping stuff out of the Casio and then putting it in here, but I couldn't find a round e-paper display. So I'm gonna have to 3D print a case at some point. Yeah, Alexis, you start off real simple with those classes. I did mechatronic engineering in university, and we did some more complicated projects. My final project was um, like a Stewart platform, which is a thing controlled by 6 motors that you can like tilt on several axes, which is pretty cool. But that was after 2 years of study. You'll get there. Yes, so that was another thing, Rugs, that I thought of to just fit the square in here, but draw a circular thing on it. But the display I got is too big for the Casio, so I'm probably just gonna make a square um, case for the watch. Since I have this space, why not use it? And I have to make a case anyway. I guess we can just look at examples. Um, they have a lot, huh? Let's just do Hello World. Mm, it is the same. Yeah, they're gonna have you do. All right, I'm gonna make sure, try to make sure I don't put any static electricity in this. This is gonna. I don't have any protective gear to make sure that doesn't happen. Okay, I see a red light. That's a good sign, probably. And then we're gonna see, what does this do? Okay. Select the location for creating host. Yeah, okay. Documents, personal. Let's just put it in here. Okay. It's in, no, it's not in Python, is it? You. Oh. Oh, okay, no, I probably did not want this. Whatever. Um, what were the other suggestions? Okay, whatever. We'll figure it out. Is there a this generate compile commands? Yes. Disk updated. Don't need to change though. Sure. I will just follow the recommendations on this. That seems fine. Okay. Now I want to know what this is. This is a testing framework, I assume. Test Hello World. Yeah. Yeah. This looks like a testing framework. That's actually pretty sweet that they help you set that up. That's pretty nice. This is more what I was expecting. This. Okay, this is gonna run on the controller. And wonder, okay, this is using standard IO. I wonder if they re-implemented printf function. Yes, they do. Okay. So that's why we can use printf. It's gonna give us information stuff. Okay. Pretty cool. And then it's gonna restart the chip. Interesting. Thank you, Alexis. You can put links in chat, that's fine. But I appreciate the consideration. So long as they're not like scam links or just for spamming. Memes, great. Love memes. Yeah, so let's see. We can. Now I'm wondering, how do we build this? What's this do? Okay, this is build compile active file. I built the compilation information. Okay, right, here we go. I actually don't really want to debug this, but I guess we can go for this. Right, okay, this is actually not what I want. Aren't there CMake tasks down here somewhere? Build? I'm pretty sure the extension is supposed to manage this for me in some way. Maybe ESP IDF? Let's see. Just gonna install the tools. Okay, once the project is created, oh, select port to use. Oh, okay. Oh wait, no, yeah, dev TTY USB 1, yeah, that seems correct. Probably correct. Available soon. Is it this one? So this is going through my monitor. We'll see if that's a bad idea. What happens if I click this again? Do I get the previous USB port? No. I'm pretty sure it's this one because these are my headphones. This is Bluetooth stuff, wireless stuff. It's probably this one. Is Pico a? No, it's just ESP32. Yep. Guess I should probably select that and clicking the status bar icon. configuration editor. What's this one? Yeah, that's going to do something. Failed to set target ESP32. Code. This failed because what? If only this was easy to read. Why did this fail? Unique. Oh. It's a pretty good controller, and it's specifically made for low powered systems. I got the idea of using it from Watchy and OpenSmartWatch. Those both use an ESP32. I figured they probably did the research, so I won't have to. I do not know what this is. Configuring incomplete. That's not good. You're scared of the 32-bit? Why? What has you worried about using 32-bit microcontroller? Let's see. I do not know what is going on here. Required. Oh. Do I not have an up-to-date? I do have an up-to-date CMake version. What's going on? CMake. Maybe I shouldn't be using the CMake extension? I have no idea. Okay. Lots of features. Oh. Yeah. Yeah, this does a lot of things. I'm not going to touch, I'm only going to use like 10% of it. I don't actually think I'm going to be using most of this stuff. All right, I'm going to go take a little quick break, like 5 minutes. I'll be right back. Right. I wonder why I'm seeing this issue. Less than 310. Oh, maybe it's more that does she make lists here? But these are just the warnings. What the heck's going on? Okay, yeah, no. Hmm. Yeah, and we're using a different one anyway. What the heck's going on? Maybe I need to be using the dev container? That doesn't seem right. That doesn't seem right. Let's see. How to use. I pressed the wrong configuration button. Configuration editor, probably. Configuration editor. Yeah. Loading initial values. Yeah, there we go. I just ran the wrong thing. Wonder what I was supposed to click. What is this? Oh, no, it's the same thing. Okay, well, I don't think I need a reproducible build. Don't need this, don't need this. Yeah, that's fine. This is fine. This is optimized for size. That's probably fine. We can do debug for now. What's this do? Oh, yes. We want this for debug purposes. Milliseconds and boots. Yeah, that's fine. Oh, read help first. What does this do? We're probably good with the defaults for the most part. Okay. 1.9 volts. Yep, this seems good. I don't think. In terms of the device factory settings, built from factory partition, the factory set. This will probably be good eventually. We don't need that now. I wonder if this chip has storage. It would be nice to be able to like save alarms and timer configurations, even if the battery in the watch dies. No, I probably don't need this. Where's side packages? No, it's fine. What's this? This is probably all. Mhm. Oh, did this also change? Oh, this is the bootloader, right? No, we definitely want that. I'm not doing anything on the bootloader. Bootloader. So we'll want that optimized for size. Yeah, the app can be uh, the app can be debug for now. We do want assertions. I think the memory flash is for the code running on, like, take this with a grain of salt. I don't actually know, but I think the memory flash is where the code you read lives. The other two are RAM slots, which like runtime memory slots. I don't think they're persistent across boots. I mean, I think if you turn it off and then you turn it on again, I don't think it'll be able to read stuff from there. I don't know though. I have I have no actual idea. Thank you for checking though. Let's see, we want assertions for now. Hmm, this is probably a good thing. Yeah. Mm-hmm. We don't want C++ exceptions because we're not going to be writing C++. We don't need Bluetooth. This. Hmm. We actually don't need the TLS library, and we're not going to be doing any network stuff. Hmm. It's really nice that they give you all these options. Okay, let's see. I think I can tweak these later. This is a lot of options. We probably shouldn't be doing this now. Okay, save. And then what did I tell you to do? Reconfigure task to generate. I think the extension already did this. Code, build your product, doing ESP IDF, build your project. So I'm gonna go, yeah, build your project. And this is gonna build, oh my god. That's a lot of build steps. See, flash to your device. Start export by pressing, okay, flash your project. If you're JTAG, I have no idea what sort of, oh, we probably have UART serial connection, just because that's what's in the schematic for in like the beginner's guide thing. Right, it'll give you those options too. Okay, start the monitor. Okay, nice. Do not know what that is. I wonder if I should just delete the CMake extension. That oh, this is CMake language support. Right. Let's just not do that. Okay, where were we? How did the build go? Right. Okay. 200 kilobytes. Not bad. That's fine. Okay. And then we want to flash part, I think. Yeah, there we go. Flash is finished. You can monitor with the monitor command. Okay. Yeah. This is the Hello World program. Nice. Okay. You got it. And it does a whole reboot. Yeah, this is ESP32 CPU cores with a PTPoE 2 megabyte embedded flash. Okay, nice. Okay, that's pretty cool. What do we want to try next? Do I connect the timer now? Try to figure that out. Well, we probably want to do something a little more interesting. Because we're gonna need it to sleep for some amount of time and then really just update every minute, I guess. We're eventually gonna have to figure that out. But I think we probably do we just go for the timer now? Probably just do. So what's going on here? Let's see. I guess this is really just printing stuff. It's not very interesting. What's this doing? Oh, this is the build. Don't need this, don't need this, don't need that. Need this. Okay. Yeah, don't really need any of this. Okay. So the timer component I have is a what? Let's see, I have is this one? Yeah, this one. This is what I have. Whatever this is. PCF 8563. This is the same clock that Watchy is using, I believe. We want the data sheet for this. Here you go. Yeah, and now I need to figure out how to wire this up. I have the FTF4. Yeah. Okay. Let's take a look at this. See if I can actually. Can this even go into the breadboard? That's the real question. I might have gotten something small enough that I can't actually put it in the breadboard, in which case we just go play with the e-paper thing. Yeah, this is for a... Oh, wait, no, that's how small it is? Oh my god. Tiny. I don't think I actually can even put this on the breadboard. It seems too small. Oh my god. Then what do we do? I wonder if there's a different part for this. It's easier to use now. Well, let's see what we can do with this. Yeah, I don't know. Like, this is what I'm holding up here. This is packaging. This isn't even the whole thing. Yes, exactly. I need very good glasses. I'm way too old to be using small stuff like this. My vision is too bad. How do I even open this? Oh, there we go. Did I do something? You know what? Let's get some tweezers. I need surgical tools. The timers or the ESP32? Which ones did you think about ordering? My first clip, great. I'm not gonna solder it. This one I might have to. I don't even have a soldering thing. Let's get stuff in here. Okay, there we go. Let's open up. I'm trying to ground myself in between doing this. I don't think I actually can. I have no grounding equipment here. Plastic is off. Yeah, like look at this. This is how. I don't even know if you can see this properly. Oh, that's how small it is. This is my finger. This is tiny. Does it even fit here? It does not. This is not going in a breadboard. Shoot. How do I test this? I don't have a soldering thing. Oh, shoot. Almost lost it already. Great. Here we go. I'm never finding this again. I wanna. Let's see. Wire tiny component to a breadboard. Yeah, I don't. Do they have a development board for the timer chip? I didn't see one here, which is why I just got the regular timer. Let's see, NXP semiconductors. NXP semiconductors. Oh, they actually have a thing here. Embedded processor development kits. Maybe I should have looked this up before I ordered stuff. Let's see. This is the what's it called? PCF 8563, whatever. If I just search, let's go back. Yeah, that tends to happen with electrical engineers and hardware stuff. Development tools, maybe? Clock and timer development tools. Oh, there we go. Yeah, that's probably what I'm supposed to be using. I have the PCF 8563T, so I. Oh no, this is 850. Whatever. What's this? This looks like maybe what I would want. Is there pins on this? What is this? Evaluation board. Solder card equipped with an Arduino board. This isn't the same chip. This isn't the same clock I have. What if we just search for this? What do we get? Yeah, nothing. Hum, hum. Do they have a dev kit on here? Design resources. What do they do? Dev kit. Yes. Keyboard. This is what I'm supposed to have. Jeez. ATC board. Okay. What if we search? See? Does Master have it? They do not. Oh, that's just real-time clock. That's what RTC stands for. This 8516. This is probably what I want. Same. Uh, yeah. All right. Well, I guess we're doing e-paper development then. I did actually get a dev kit for the display, so we can actually do something. Yeah, Mauser is great. Um, I say as that's the only place I've ever bought from, but still, it was great. Great experience. I also like they shipped this yesterday evening and it got here before noon. That's crazy. Okay, same thing. I'm gonna get this. Okay. Yeah, so I did actually get a dev board for the e-paper display. I went on the oh, nice. They require a 2 hour call before you go. Yeah, it's great shipping time. If they need you to call um, with a 2 hour, like 2 hours before you go, they must be busy. I'm supposed to plug this in. So I'm gonna break something. It has to click in, right? I'm so worried I'm gonna break this. Yeah, so e-paper display. Trying to connect this. See, I don't want to grab this with the tweezers because I'm worried I'm gonna ruin the connectors. You always learn something useful while making memes for the internet. This has to be has to go deeper. Almost. I'm gonna ruin this display before I can test it, aren't I? Jeez. Yeah, Mouser seems to ship all over the place. Oh, okay, I don't think I ruined anything yet. What? You know what? Maybe I should just look up how to plug this in, just to make sure I'm not doing something horribly wrong. This is pervasive displays. How to plug e-paper pervasive display port. Okay. Uh, well, here we can see one plugged in at least. Oh, is it supposed to go through the hole on top? Is that how this works? That cannot be how this works. I refuse. I refuse to believe that. No, it's supposed to go in through here. Has to be. Yeah, they only use power when you're changing the image. And then once the image is changed, it's constant. It's really, really cool. Oops. Yeah, here we go. This is the, sure, let's try it here. This is the one I have. Or this is the kit I have. So it's just barely in there. That's really what it's supposed to be like? That seems so finicky. Well, okay. I suppose that's what we're doing. Glad I didn't try to force it harder, I guess. Might have been smarter to get the actual board that's already hooked up. I think they have one of those. That might have been easier. Anyway, I have the, just double check number on this. I have a link to this in my email. So this, I think, is the display, and this is the extension thing. Did this come with a data sheet? That's fine. And it's already labeled. Nice. Okay. Then we're good. So this data sheet. I need some way to talk to the monitor. Let's find the pin information on this. Let's have ground. Okay. Plug the power, and now we're gonna need these. And this is going on the ground pin. Now there, it's grounded. We're going to need something else. Does this not have a data sheet? Nope, it does not. Okay. Yeah, we're on 3 volts. Hmm. Pin assignment, here we go. Data command and control. Power supply. Logic pins. This should be connected with the power supply for the chip. I do not have this many pins. That is rough. Oh, wait, no, these are the pins on the display itself, of course. Ay. Okay, let's see. DC, that is VDDIO ground. I think I'm supposed to use the VCC for input, like the power. The data bus. Yeah. Like I have a pin labeled VCC. Yeah, that's what I expect to be the power. I was hoping to find confirmation on that. I guess we're not getting that. We'll try. It's fine. Worst case, I suppose I can always buy another one. This is going to power. And then we're going to need a way to connect the microcontroller to the pin. Oh boy. Am I going to have to do this? Does the development board not do this for me? I think it does this for me. Hope it does this for me. Pretty sure it does this for me. So I do not have any of these pins on my board. I only have what, 12? Yeah, 12 pins. I don't think I have to do this on the development board. Okay. Let's see. Let's see. Did I miss the communication protocol on this? Hmm. Hmm, hmm. Yeah, they don't have protocol for this in here, for how to actually draw. Is this just electrical stuff? Just an SPI interface. 200 by 200 pixels. This black white. Just electrical, huh? That sucks. Okay. Mhm. Okay, I'm gonna need something to connect to the busy pin because it's not supposed to receive output. Yeah, the data pin. There's a reset signal as well. That's probably gonna be useful. Yeah, I do see that one. See the reset and the busy. I do see the DC for data. Yeah, data command, I suppose. What are all these other pins for? Wonder if I go just find this on the pervasive displays website, that it's going to give me some more information on this. Pervasive displays. The joy of hunting down datasheets. I cannot search. Okay. Oops. Let's look at that. Let's. And maybe it has it here. I think I have this extension kit. The ext31. ext3 EPD. The one I have. Okay. Mine looks like this. Oh yeah, it says on here, ext31. Hmm. Yep. Oh wait, right. It came with a whole thing. I forgot about that. Oh yeah. Thank you for tuning in, Alexis. See you. I forgot about that. It came with a whole thing for the pins. Everything except the power, I suppose. Oh, it only does two. Everything except two of them. How to work with the AXT31 kit. Port striving 1.64 to 2. And board layout. Yeah. Yeah. Connecting ABK. Okay. Okay. So I need to put this on. It's a tight connector. Wow. There we go. Okay. Okay, so we don't need the two top pins. That's good to know. So white is brown for this one. Oh my god. Okay. Great. Hook up another wire to. Oh my. Hmm. I guess I need male to male pairs. We do have some more, thankfully. Goody goody. Now I just need a knife. Yeah, I need to go get a knife. Hang on. Okay. Got a knife, so we can hopefully get these wires. Who packed this? Oh, this is gonna make such a mess. Wait. So there we go. Okay, grounded. Okay. Oh, you're supposed to open the connector. That's why I couldn't plug it in earlier. The heck are you supposed to do that? Oh, what's happened there? Oh no, it is. Oh, it is open. So then you put it in, and then you press the thing down. Ah, there we go. Properly plugged in now. Okay. Right. Then wiring to hmm. See, the Arduino might be more useful. Hmm. Yeah, black one is how. Need to get one of those. Okay. No, I just to. Right, this goes to GPI opens. Hmm. I have a driver library. It's actually probably not what we want. Oh, here we go. Yeah. SPI claw. Okay. Let's see. For control. I think I can just connect these to any GPI opens, and then I can do the. Yeah, I can be in control of everything going. Okay, so now I need the 32 again. Are any of the pins on those pin descriptions? Okay, yeah. We have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13 GPI events. Oh, on one side and then more on the other. 2, 3, 4, 5. Oh yeah, okay. We've got a bunch. 37 GPI events. Okay, yeah, we're good. Clock out, that's probably what we want. Hmm. Hmm. Level clocks out. It's good to know. That's probably what's supposed to go into the SPI clock. Right. EPD usage. EPD derived sequence. Which is the correct one here? It's wrong. This one? Wide temperature EPDs. Sure. We do. This is gonna take so long to figure out. Yikers. Okay, panel drawing. Sure. Yeah, this is the 1.54. That's the one I have. Okay. Well, mine is 200 by 200, so this is. Let's close this. This is a EFT EPD panel, whatever that means. No. At large. No. So PWRI. Why? Host sends both designing commands and with SPI bus. Okay. That's good. Figure this out later. Okay, this is what I need for drawing, at least. That's good. Oh, nice. I don't have DevKit C. but this is most likely going to be the same thing. It probably does have a timer on it, since I mean I assume so because you can have it wait for. Sorry, it took me a long time to reply. I was um, in deep, but it probably does have a timer on it because this has a delay function. Oh, it's just for number of ticks on what it estimates based on the tick rate. Okay. Yeah. Okay. So maybe it doesn't have a clock, just as a tick rate. I think clocks are typically complicated. I don't know. It seems better to use an external clock for accuracy. Okay. C++. Well, that. Okay. Mm, mm, yeah. This is like a library that works with multiple sizes. I'm not sure we need to use this. Okay, that's fine. Uh, Related documents, Pico v3 datasheet. Going to be using SPI. Yeah, it's a real-time clock or whatever that stands for. It's I had it open here. It is this one, I think. Real-time clock, ultra low power. Yeah. For a watch, it seems important to have accurate timing, right? That's what I thought, at least. I wanted my clocks to be accurate, so that's what I got. Let's see. Looks like it does have a real-time clock, RTC, maybe? Who knows? To 34 GPIOs. Pico. I'm not sure which version I have, but probably this one. This one. All right. Guess we'll want the pin layout. Did I? Which one do I have? It's the V3. Yep. Okay. No. I'll pick this one then. General purpose input and output. That's oh no, SPI is what we're going to want to use. Let's look at the pins. Yeah. I wonder if these have the same numbers. No, they probably don't. That's okay. Because the kit has its own numbering here. That's fine. Pin description. Input only pins. Themselves and get pins that are connected to the in-package flash. Okay. I don't actually know what that means. Hmm. 6, 7, 8, 9, 10, 11, and 20 belong to the STI. Cannot work when the STI version's done. Okay. Signals of SPI. Red star is clocks. Okay. So it does have pins corresponding to stuff. Okay. Probably want to look at the SPIO interface. Programmable clock, SPI controller. This is going to be so much reading. Okay. SPI controller, is that a thing on here? List of tables is what I want. Let's see. Oh, they have something here. SPI slip controller. Probably what we want. ESP30, ESP32. Okay, nice. Oh no, 404. Oh no, it got it. Nice. Okay. Oops. Okay, so we can figure out, yeah, that clock. Okay. We have some diagrams. I just don't yet understand what actually needs to be connected to the development board here. Sounds like, so we definitely need to be able to read the busy state. We need to connect the clock so that they can be in sync, I think. We want to be able to send the reset signal. This is what I want. Driving circuit. Circuit. Okay. Didn't I get a 1.52 inch display? Am I reading the wrong stuff? Uh, it is a 1.52 inch display. Great. Okay, well, hopefully they haven't changed much. Okay, so oh, this is what I was looking at earlier. This isn't really. Okay. Hmm. Okay, we're not dealing with the real-time clocks yet. Okay. So, silence. Um, hmm. So this connects the clock I do not have my display isn't big enough to have the ECSS and FCSS, so we wanna, oh yeah, looking at the ECSM, CSM, we'll see the reset, the TC and the busy, okay, that at least helps. And the question becomes more of, where do I wire in each of these here? There's a, nope. So I just need to figure that out. Okay. Let's see. It's gonna be the SPID clock and SPID clock. And then I need to figure out which is which. I'm probably gonna have to read this entire chapter. Yeah. I will do that in my own time, I think. It gives me the registers, that's nice. Okay. That's all good, that's all good. That's a lot of registers, wow. Okay. All right. What I wanted to see was, right, where's the SPID pin? I assume there's going to be a SPID pin. SPID. So that's going to be IO13 on pin 11. Just on the side with the light. And that's the mouse here, right? That's what I think. Yeah. Hope I'm doing this right. Where's the mouse? The blue. I think. Yeah. Let's grab a blue one. That's green. It's too long. There. Okay, send the blue one. It's gonna get hooked up to, was it pin 11? Oh my god. It does not have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Can this be correct? The 11th pin is number 13. That feels so long. Original components. See, there isn't an 11 on this. That's just. IO. Oh, it says IO13. So yeah, that would be pin 13. Or those. Once this is connected correctly, I am never taking this apart again. Okay, and then it was said we need something to go. I guess we're gonna hook up the claw. It's gonna be. Okay. Okay. HPI clock, that's probably the one that. So IO14 or the clock should be the 9th pin. Yep, but that's. And what's the color of the clock? It's the SCK, it's the brown one. 2. Okay. Brown. It's orange, the closest we can get. I think so. Orange is almost brown. Too bad there's an orange wire there already. We have a brown one. I do not. Do I have a color that's not on here? No, I do not. Orange it is. Just brown. It's going to pin 14. Yeah. Thankfully, that was just a tool. Let's see. Yeah, IO14, number 9. Okay. And I do not know what ECS and FCS are. What are those? Maybe that's in the datasheet. It's not. Why would it be? Um, what else do we have in here? We've connected the mouse and the clock. Hey. Uh, hmm. Mhm. I might want to just look up. Yeah, I'm gonna have to just look up a pin thing for the Raspberry Pico. Raspberry Pico. Does it say whether it's to a Pico? Pico 2? 2040. That's probably a 2 thing. Okay, here we go. Oh no, it's this one. Pico and Pico H. Yeah. Let's see. We have that. We can look at the uses. GP10. Okay, so it's flit. I mean, it's easy. So SPI. Which one is that? Flash. Yes. Feel like something isn't right. Is it just mirrored? Use the out. It's like it's mirrored on this. Yeah, it's mirrored. Ugh. Okay. Okay. Uh, yeah, it's just mirrored. It's weird. Right. Yeah. Odd, but okay. So Flash CS is gonna be, oh, the MOSI is on CP19 is what it says here. Yeah. Which doesn't tell me anything. I think these are just general purpose registers. Maybe it doesn't matter. Only that it goes on SPI pins. Okay. Uh, that's not relevant. Like I need the pin descriptions. Does this give me somewhere something like? I don't think it really matters. But I'm gonna call it a day. It's getting late here. I should go to bed. At least we made some headlines. Right. And I just cleaned up. I've made a mess again. Keep the hanger back in the bag. I don't think I'm gonna be using it, but who knows? Who knows? These are all going back in a box. Wires, 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 and wires. These. Yeah. Everything cleaned up? Sort of? Kind of? Okay, well, thank you everyone for tuning in. This was fun. Thank you for coming to watch me stumble through this. I don't know how much headway we really made, but at least we have the microcontroller working. Maybe next time we'll be able to figure out how to hook up this display. Yeah, thank you, Rox, for tuning in. Maybe I should see if someone is streaming that I follow that still has something similar. Uh-oh. Well, I gotta run. Baby's up. See you. Bye-bye.